Yeah, hi guys. So today we are going to solve maximum subarray sum with length divisible by k. It is a very important question because not only it has been asked on big tech companies, but it also helps in evolving the logic that we already have for prefix sum. It introduces an edge case. And that edge case honestly was a little bit tough to understand. Also, the question statement was not making it very easy. My goal is basically to explain you the thought process, so if any similar question comes you will be able to solve it. Okay, without wasting more time, I'll just go to the question. Okay, so the question says maximum subarray sum with length divisible by k. Maximum subarray sum with length divisible by k. You are given an array of integers nums and integer k. Return the maximum sum of the subarray of nums such that the size of the subarray is divisible by k. Basically, you want to return a subarray. So there could be n number of subarrays. You want to return the sum of that subarray which is maximum than other subarray, but with a twist. The length of this subarray should be divisible by k. Okay, what it means? So, in order for that to begin, I just wanted to explain or give a revision quickly on how do we find a subarray sum, right, for any particular index I to j. So let's say I have this array 1 2 3 and my prefix sum would be 1 3 6, and now if I want to find the subarray sum of these two, 3 plus 2 5, how can I find it quickly? What I can do is I can just pick the whole thing and subtract this part. I can pick the whole prefix sum and subtract this part, which would essentially be prefix sum of this point to prefix sum of this point, difference between, right? So let's say if I am I at here and j at here, which is this, right? So I can do p of j minus p of I minus 1, which would be 6 minus 1, which would be 5, and this is also 5. So think about it, pause this video for a second, revise this concept again because this is going to come in handy. Second thing is, how can I find maximum subarray sum? If I am not given anything, which subarray in a array of n length would be the maximum? So a famous way of finding this is cadence algorithm. Basically, what cadence algorithm does is it keeps a track of all the current subarray. Keeps a track of the current subarray sum, and it drops it if the new number is greater than the running subarray. It drops it if the new number is greater than the current subarray, and then it keeps a track of the maximum number as well. So what it does is, let's say if I have an example of this, if I can start from here, basically I can always start from here, I don't have to go here, because otherwise I will have to initialize my number to infinity, right, for this type of question actually. So I'll take the current number and I'll hold the current subarray also. I'll see if this number is greater than the current subarray sum. If this is not, so because the current subarray sum is initialized with the first number, right? So if this number is greater, then I'll try to start a new subarray which will become my current subarray, right? And whichever length is greater, maximum subarray or the current subarray, I will give it as a result, right? So just to highlight, so let's say that my current subarray and maximum subarray is minus 2 as of now. I'll start it from here. My current subarray and this. If I take this, what will be the sum? It will be minus 1. But if I start from here, what will be the sum? 1. So I will drop this. Guy. So my current sum is now 1. My maximum sum is also 1. Now I'm here, right? So here at this point, what is my current subarray? Current subarray is 1 plus minus 3, which is minus 2. Or if I start with here minus 3, which one is greater? Minus 2 is greater, right? So I'll anyway pick it, but it is not bigger than my maximum subarray. So still the subarray 1 is greater than this 2, right? Now I can, since I am still here, right, I can move till here. I'll see what is the sum. So here the sum is 1 minus 3 plus 4, which is minus 2 plus 4, which is 2. But is it greater? Can I restart? I can restart because this number is greater, right? So my current sum, sub-array sum will be 4, my maximum will also be 4. I can start from here. Now I can take this number, or I should avoid this number in order to find the maximum sub-array. The maximum sub-array here is 4, right? So it would be 3, and the current sub-array is 4. 4 is greater, 4 is the winner, 4 is the number. So this is one way of finding current maximum sub-array sum, right? Without any constraint. So cadence algorithm is also going to come into picture. So just revise these two, what I have said, for like 3 seconds. Pause this video for 3 seconds. Think about these two if we want to solve the whole question, right? So one. Okay, so coming back to the question with the trick, the observation, the intuition that we need to solve this problem, the trick that we need to solve this problem, right? So I'll just rub this part, not needed for now. Yes. Okay, so I've already told you like how we can find the sum of I minus j, right? But what we need to find is maximum sub-array, right? Maximum sub-array. So let's say that I have this point and I am at 19, right? My j is fixed. Now one of the prefixsum that I see, because p of j minus p of I minus 1, one of the prefixsum at p of I minus 1 I see is 2, and one of the prefixsum I see at p of I minus 1 is 7. So can you tell me which sub-array will be bigger? If I do 19 minus 2, it would be 17. But if I do 19 minus 7, it would be 12. So which one is bigger? Which one is giving the maximum sub-array? This one, right? This one, because whatever number that were there resulted in the prefixsum 19 from here. Also from here also it resulted in 19, but the maximum sub-array would be this one, right? Because if I subtract, this is what I'm getting. This is simple maths. Think about it again for a few seconds, then pause the video and come back, right? Now, so the formula that we got is, if I have the prefixsum and if I minus it with the minimum prefixsum, right, I will get the maximum sub-array sum. So in a question, right, there could be different sums at different point. So what I'll have to do is, I'll have to find the maximum prefixsum, comma, sum minus minimum prefixsum, right? Because whatever the maximum, that would be the final answer. Okay, what I'm telling you is, so the constraint here was the sub-array length should be divisible by k. That means at any index I, if I is equal to, if I mod k is equal to 0, then only that sub-array will be considered. Correct. Then only that sub-array will be considered. So let's say that I have again sub-array 1, 0, 1, 2, 3, 4, 5, 6, right? I have 0, 1, 2, 3, 4, 5, 6. Now at each index, what would be the remainder? So 0 mod, if k is equal to, let's say 2, basically see how many sub-arrays, before seeing this, if k is equal to 2, we already know that the number that are fully divisible by k is the 0, then it is 2, then it is 4, and then it is 6. This we already know, right? I hope that we already know. So the sub-array can be formed for this it could be from 0 to 2, it could be from 2 to 4, it could be from 4 to 6, it could be from 0 to 6. If 6 is constant, what if 5 is constant? It would be 5 to 3, then 3 to 1, right? It would be 5 to 3 and then 3 to 1, and then it would be, it cannot be more, right? It cannot be more. Fine. Okay, got it. Same for 4. It could be, if the 4 is static, then it could be 4 to 2, right? Then it could be 2 to 0, right? Or it could be 4 to 0 also, right? So this is what we know. So in order to find, right, what is the similarity between 4, 6, 2 and 0 is, if I divide it by 2, all of them will result in a remainder 0, right? If I divide by 5, 3 or 1, all of them would be resulting in a remainder 1. So there are only two possible ways I can see for k is equal to 2. So what I will do, I will create an array where I will say, okay, I will store the minimum prefixsum. If something I want to store is the minimum prefixsum, right, what I have to do? What I have to do so that the value can be replaced, right? Because that value can be. So what I will do here is, basically, I will fill it with a very maximum number so that any minimum number can be replaced by it, right? This is a very famous trick that we have in lot of questions. So if I want to hold minimum values, I will initialize with maximum values. So I can initialize it with maximum values, but there is a catch. But here there is a catch. Catch is like, the sub array can start from the beginning also, right? So if I do it infinite, this doesn't work. So what I have to do is, either I have to initialize this as 0 or this as 0. So I will initialize this as 0. Okay. Now coming back. So 0 mod 2, 1 mod 2, 2 mod 2, 3 mod 2, 4 mod 2, 5 mod 2, right, and 6 mod 2. So here it would be like I was saying, it would be 0, it would be 1, it would be 0, it would be 1, it would be 0, it would be 1, it would be 0. So what I will do is, I will only hold the minimum prefixsum, because if I am at any point 6, right, I want the minimum prefixsum, whichever was the minimum prefixsum for this point, this point, or this point, to find the maximum subarray sum. So two very important things is, to find maximum subarray sum, we need to find the minimum prefixsum for a valid length. Valid length is I mod k, which we can do with the help of this array, right? And always we will update the prefixsum, minimum prefixsum. So if I find a running sum which is lesser than the existing minimum prefixsum for that particular index, right, I mod k, then I will replace it. Okay. So one more example here. Let's say n is equal to 2, 3, minus 1, 4, k is equal to 3. So the remainder I will create will be like this, because 3, 0 mod 3, 1 mod 3, 2 mod 3 and 3 mod 3. So 0, 1, 2, 0. The prefixsum for this would be 2, 5, 4, 8, which will be created on the fly for all indexes. Then the minimum prefix, how will I store minimum prefix in an array of this, infinite, infinite and 0. I have already told you why the 0 is there. Please check this 0, okay? You guys need to understand why this 0 is needed. Also in the hash map approach, where we use prefixsum, the first element we store was 0 to 1, because if the subarray can start from the index 0, then how we will know that this has been came as a count again, right? Please check my previous video. Right. Now my new minimum prefixsum, I wanted to show you this, would be at every point would be, so if I am at index 2, the prefixsum is 2, so it would be, I will initialize the result, right, because it would be a very big value, so I will initialize it with minus infinity. So I'm sorry, so here it would be result comma sum minus minimum prefixsum of this k, I mod k, right? So here the sum is 2, minimum prefixsum is infinity, right? So 2 minus infinity is minus infinity, and the sum that I have stored is also minus infinity, so this nothing changed, so sum remains minus infinity or infinity, let's say infinity, right? Same thing. Then for 5 also the same thing happens, because anyway the minimum prefix sum here is infinity. 5 and infinity, which one is lesser? 5. But also I will update it, right? So at first I will update 2, then I will update 5. Now coming the main part here. Now I am at this index, right? The remainder would be 2 mod k, which would be 2, right? The 2 here is 0. I am at this number. If I want to find the prefix sum, I will do 4 minus 0. I will do 4 minus 0. The sum would be 4. My 4 is greater than minus infinity. So the maximum subarray sum right now is 4. Maximum subarray sum is right now is 4. And the minimum prefix still holds 0. Minimum prefix still holds 0. Right. Now I am at the index is, my prefix sum, running prefix sum is 8. Sorry, my running prefix sum would be 6, right? My running prefix sum would be 6. 2 plus 3 is 5, 5 minus 1 is 4. My running prefix sum would be 8. What am I saying? Right? My running prefix sum would be 8. Okay, sorry. So what I will do is, this thing is pointing to 0th index, which is 2, right? So if I want to find a length of 3, right? If I am at this point, I want to find k is equal to 3, right? So this would be it, this would be it, right? So what I will do is, I will whatever the prefix sum of this minus, I will do the prefix sum of this. So how can I find that? I can find that minimum prefix sum of this, right? Which would be 0. So 8 minus 2 would be 6. So the answer to this question is 6. So I know that this question is a little bit tricky to understand. What I want you guys to understand this part of the question, right? I want you guys to understand this part of the question where I was doing p of j minus 1, right? Main is this part. Please go back and watch this to find how do we find the max subarray we need to find the minimum prefix sum for a valid length I mod k. If you understand this part, then solving the question is very easy. Okay, so I have some time. I just wanted to say that making this video takes time. So, and I really want to improve, right? I really want to improve on my explanation. So commenting would really help and would really support me. So please comment. Like if you want, you do. If you don't want, you don't do. But please give me feedback. Okay, so see you guys on next video. Bye bye.